there are some equations that can be reduced to homogeneous differential equations. Specifically, if your differential equation something look like this, that means on the right hand side you have division of two functions like this, where a, b, c and a dash, b dash and c dash are constant, you can reduce this type of differential equation into homogeneous differential equation. To do that, first you have to compare the coefficient, ratio of the coefficient between x and y. That means you have to compare these two ratios. You have to check this is equal or not. Depending on this is equal or not, you have to follow different method. So let's first consider scenario this is equal. That means ratio of the coefficient between x and y is equal. Let's consider an example. Dy by dx equals x minus 2y plus 3 divided by 2x minus 4y plus 5. You can see that this is not homogeneous differential equation because of these constant. If those are not in here, then this is homogeneous. Now if we consider the ratio between coefficient of x and y, you can see that it is equal. A here is 1, a dash 2, and b is minus 2, b dash is minus 4. So this is half, and b over b dash is also equal to half. Therefore ratio between these two is equal. Now if this ratio is equal, we can find out common factor from the numerator and denominator in terms of x and y. You can see that from here, if we take out 2, this term is common for denominator and numerator. So take this as substitution. That is the method. So let's write it here. Take x minus 2y as our substitution. Let's take it as z. You can take any letter. Now if we differentiate this with respect to x, 1 to dy by dx dz by dx. So we have to remove y terms here. Now to do that, if we move 1 to the right hand side and subject the coefficient dy by dx, we end up with half time 1 over dz by dx. Now we have the term dy by dx in terms of dz by dx. We can substitute it into here. Now given differential equation becomes something look like this: 1 minus dz by dx. X minus 2y equals z plus 3. This is also z, that means 2z plus 5. Now if we multiply entire equation by 2, we come up with differential equation look like this: 2z plus 3 divided by 2z plus 5. Now we can simplify further this. If we move dz by dx on the right hand side, this is 1 minus 2z plus 3 divided by 2z plus 5. If we simplify this further, we are end up with something look like this: 1 over 2z plus 5. You can see that now this differential equation can be solved using the separation of variable method. Now move all these terms into the left hand side. 2z plus 5 dz equals minus dx. Now integrate with respect to relevant variable. Now this is 2z squared divided by 2, that means z squared. 5z equals minus x plus c. Now we can remove our substitution. We take z as x minus 2y, so we can remove our z terms from the final expression: x minus 2y minus x plus c. If you want, you can simplify further by expanding this and using some algebra. So final expression look like this: 4y squared 6x minus 10y equals c, where c is an arbitrary constant. Now if we consider the scenario where ratio between coefficient of x and y is not equal, then we have to follow different method. For example, consider this differential equation. You can see that a is, let me write it here, a is minus 1, a dash is 1, and b is 1, b dash is 1. So ratio between these two is not equal, then you have to follow different method. So this differential equation is not homogeneous due to the constant terms in here. Somehow we have to remove those terms. To do that, we use this substitution. We substitute x as capital X plus h and y as capital Y plus k, where h and k are constant. So if we substitute, and you can see that if we differentiate this respect to x, or if we consider differentials, then dx equals capital dx because h is constant, dy equals capital dy, so dy over dx equals capital dy over dx. So we can substitute that here. Now if we consider this becomes dy over dx minus x. X means capital X plus h, simple y means capital Y plus k plus 1, and capital X plus h, capital Y plus k minus 5. If we simplify this further, dy by dx, we get something look like this: x plus y minus h plus k plus 1. I write x and y from the beginning. Now x plus y, h minus k minus 5. You can see that these terms, if we get rid of these terms, this differential equation become homogeneous. To do that, we can solve this simultaneously, get rid of these terms. So h plus k plus 1 should become 0, and h plus k minus 5 also should be 0. Now if we solve this using you can solve this, and value of the h equals 3 and k is 2. You can check that. Therefore our equation becomes something look like this if we choose h and k as this. So our differential equation become look like this for h equals 3 and k equals 2. Now this is homogeneous differential equation in terms of capital X and capital Y. Now you can put y, our substitution, capital Y equals Vx. To solve this, we already know how to solve homogeneous differential equation. So differentiate with respect to x, dy by dx equals v times x d by dx using product rule. Now our differential equation becomes something look like this: x times dv by dx equals minus x vx divided by x plus vx. If we simplify this further, this look like something like this v. Now you can move this v to this side and simplify further. You will finally get differential equation look like this: 1 plus v squared divided by 1 over v. Now this equation can be solved using variable separation method. So I will do that here. our equation is by dx 1 plus v square divided by 1 over v. Now move all the v terms into the left hand side. 1 plus v squared minus 1 over x dx. Okay, now to integrate this, we have to use partial fraction, or you can divide this separately by 1 over v squared. You get something like 1 over v squared, and you can make derivative of the denominator in the numerator if we multiply this by 2 and divide this by 2. So you can use integration formulas very easily to integrate this. So this is tan inverse v. This is half time ln 1 plus v squared. This is ln capital X plus c. Now we know v is equal y equals vx, so v is equal to y over x. We can substitute it here. Capital Y over x half times ln 1 plus capital Y squared divided by x squared minus ln x plus c. Now you can simplify this further. Ln x squared plus y squared divided by x squared minus ln x plus c. Now this is in terms of we can simplify this further. If we move this ln x into the left hand side, now what happened? Actually before that, I will simplify this further using some logarithmic rules. X squared y squared minus ln x squared. So minus ln x squared is equal to 2 times ln x. This is also by logarithmic rules. So now our equation becomes something look like this: half time ln x squared plus y squared, 2 times minus 2 ln x equals minus ln x, and it will cancel with this term on the right hand side. So our final expression look like this. Now this is in terms of capital X and Y, our original equation in terms of simple x and y. So how to substitute that to get our original expression? To do that, we know we consider here we use these two substitution. X equals capital X plus h, y equals capital Y plus k, and our h and k is equal to 3 and 2. So we can use this information here. Our simple x equals capital X plus h, capital Y plus k, and our h equals 3. This is equal to 3. This is equal to 2. That means capital S equals simple x minus 3 and capital Y equals simple y minus 2. Now we can substitute this information to this expression, and we can obtain expression using our original variables. So tan inverse y is equal to y minus 2 x minus 3 half time ln x minus 3 squared y minus 2 squared equals c. Now tan inverse y minus 2 x minus 3, this is our solution. If you want, you can simplify further. You can expand this and using some algebra simplify this. So our final expression look like x squared plus y squared minus 6x minus 4y plus 13 equals c. So this is our final solution to this differential equation. To summarize up, if we have differential equation something look like this: dy by dx equals ax plus by plus c, over a dash x b dash y plus c dash, then we can reduce these type of differential equation into homogeneous differential equation. To do that, we compare coefficient ratio of the coefficient between x and y and check whether it is equal to each other or not. If it is equal, we can find out common factor from the denominator and numerator and substitute using some variable to this common factor. Then you can reduce your equation into homogeneous differential equation. If this ratio is not equal, then what you have to do is take simple x as x plus h and simple y as capital Y plus k, and dx is capital Dx, dy equals capital Dy. So dx by dy equals dx, dy by dx, dy by dx equals dx. So you can obtain new differential equation in terms of capital Y and capital X, and using terms h and k you can substitute for x capital X plus h, and you can simplify and finally get something look like this. For if we show our example like this, so you can get rid of all the terms, constant term, if we choose value such that if we choose some values for h and k such that this constant term becomes 0, then we are end up with homogeneous differential equation without constant terms. So choose value such that throw in these two equations simultaneously to get rid of those two terms. So finally you can solve this using method you learned in the previous video, how to solve homogeneous differential equation. So finally you can substitute again using h and k value you obtain here. That's all.